So, the first part was just going back to the definitions of population versus sample. Population is the entire thing, sample is a part of it. Always ask yourself, are there more? So if I have a study of 254 patients with sleep disorders, I say, are there more? Yep. So the population is all patients with sleep disorders, and my sample is 254 patients from my population. Now they have to be patients with sleep disorders. That's your population. Okay, then we went through, stop me if there's any questions, okay? Then we went through a couple of definitions: nominal, ratio, interval, ordinal. Nominal name, number, has no mathematical meaning. Ordinal, some kind of order, small to large. Ratio is the highest. Interval is more your temperature, your time. If you can say it's something half as much, twice as much, it's ratio. Anything that counts anything is ratio. So the numbers on your shirt, nominal.
For C, it says the finishing times, like, wouldn't that be in order too, though?
It's not really order because it has, you can tell the difference between them, you can tell the difference, but...
Wouldn't it matter if someone got first or second, or third, or fourth?
Well, that's finishing places. That's finishing places. Like the finishing times, it depends how you look at this one. If you say you ran 26 minutes and then 45 minutes, then you're going to have ratio. If you look at the times, like 4:01 and 2 seconds, then you have interval. If you got a finishing time, this is a finishing time. Like when you clocked in, it ran at this. This was your time.
Yeah, but so many times we doubled somebody else's time, so.
Well, then you're looking at this part of it. So either way you go with that, I'm fine. It's a really core type question, but I wanted you to see the difference. An interval says 0 is a time and not an inherent 0. Like, doesn't mean nothing, like a temperature. Temperature is your best interval. Temperature says this: positive 10, 0, negative 10. Their 0 doesn't mean nothing. Their 0 means that's the temperature. You have 0 degrees. So that means that's interval. A ratio, you can tell the difference between them. Okay? So if you either gave me ratio or interval and explained what you did, that's fine. I wouldn't ask that on the final because that's kind of like an iffy type question. Okay, we went through experiments. We went through sampling, census if you're a population. We went through all the different types. We did simulations up here. We did experiments, simulations, surveys. Those were your different types. Yes.
Was this on here observational study, or is that?
If you want to see an effect of something, if you want an effect, how did it change? It's an experiment. If you're just observing, you're observing people eating, maybe their eating habits, you're just making an observation. If you do something to change something, it's an experiment. And remember, if this is a dangerous thing, it's a simulation. I can't give somebody radiation to see how it affects their body. I can do a simulation on a computer or a machine or something because that would be harmful to them. Okay? And I put it in your notes, all the different ways. So keep your note page handy. As a matter of fact, let me just pull up a note page. Because I think your notes, it's easier for you to look at those. I'll refer to them when I don't have them in front of me. I kind of sectioned it out for you. Level of measurements, data collection, these are your different ways to collect data. Here's your sampling techniques underneath. Your random sampling, your convenience, your stratified, okay, your systematic. So know those. Make sure you know those. Different ways for sampling techniques. If you ask people at a beach how they feel about water pollution, they're going to feel very strongly. They're obviously at the beach. That's a convenience sampling. That's where your bias comes in. This has bias. You have to ask random people, not just people that it affects. That's why you have to be careful when you give out a survey, such as that survey that was in the paper about casinos. What ends up happening is you really respond when you feel strongly about something. Like how many times do they tell you, could you please take this survey? And if you feel like, it's all right either way, do you take it? No. But if you feel very strongly like, oh, I absolutely love this, I want to tell them, or I couldn't stand this, I need them to know, your strong feelings are the ones that usually respond to those surveys. So be careful of those types of things. You don't want bias in your study. For quality assurance, every 5th engine part is selected and checked. Systematic. Same as when you line up in gym. You count off 1, 2, 3, 1, 2, 3, all the ones, all the twos. Systematic. When you identify parts of each group, you take some of the freshmen, some of the sophomores, some of the seniors, some of the juniors, stratified, like a rock, stratified. Cluster is when you take all of one group. I'm going to take all of the sophomores. That's a cluster. Think of a cluster like a zip code. Everybody belongs to this area. I'm going to take this zip code. Stratified, I will take some from Newburgh, zip code, some from New Windsor, zip code, some from Cornwall, zip code. Stratified. See the difference? It kind of makes sense when you think about it. Stop me again if you have any questions. This one said you have 25 people and you had to make a frequency distribution using 5 classes. Class limits, midpoints, frequencies, boundaries, relative frequencies, cumulative frequencies. On your notes, I kind of gave you a little bit description. Relative frequency is the part over whole, the class frequency over the whole frequency, over the whole sample size. And I gave you a list of the graphs. It might be helpful when you do this, when you work on these, to put your own notes in here. What did you use for your XY axis? How did you label it? What are you looking at? The most important part, and I can guarantee you're going to see one of these types of graphs, you're going to have to set up a table, is how you start. You're going to take your maximum minus your minimum entry. So my maximum entry is 157. My minimum entry, 101. I subtract them, I get 56. Then I divide by how many classes there are. I want to take those and separate them into 5 classes. When I divide them, I always round up. So even though this came to 11 point something or other, I round up. Jen?
For class limits, does that matter?
It absolutely matters. You have to follow this.
No, how do you get the class limit?
How do I get the class limit?
Yeah.
Because once you do this, you're going to start with your smallest one. You got this part down?
Yeah.
Okay, so watch. We start to start your table. Start with your minimum entry, 101, and add 12, your class width, all the way down. Add your class width. So you're going to start like this. 101 is your minimum entry. Add 12, 113. Add 12, 125. Add 12, 137. Add 12, 149. That's how you start. Then the other part of it goes like this. What comes before 113? 112. And just add 12 all the way down. If you want, your 12 is your class width. Your class width will help you set up your whole entire part here. Add 12. All the way down like this. If you look at one interval, 101 to 112, there's really 12 pieces of data in there. We subtract and have to add 1. So rather than get hung up on that little mistake, go this way. It's much easier. Your midpoint, take the 2, divide it in half, add them, divide it in half. There's your midpoint. Then add 12 all the way down. Right? 12 is your class width. Your class boundaries, it's just like expanding the bar a little bit because these are discrete values. So from 101 to 112, I have a gap to 113. So I want that boundary to meet. So I lower the lower limit by 0.5, I raise the upper limit by 0.5. So that I should see this now. I'll never hit a number that's 136.5, so I don't have to worry about that when I count my frequency. But I do have to worry about that when I make my graph. Do your tick marks, get your frequency, your relative frequency, your total frequency here is 25. When you do your cumulative, start with the smallest, then add the next one, add the next one. This should be your total. And your relative is part over whole, 3 over 25, 14 over 25. See it? That's your relative. Your relative frequency is the same as your probability one when we did probability. And you should know how to do these graphs, because it'll be one of the graphs that I asked you.
Wait, but how do you find the frequency like for each individual one?
You do your tick marks. Make a tick mark thing. Like if it's 25, put it in this. If it's 101, tick mark. 113, tick mark. And then add up your tick marks at the end. I just didn't put the tick marks there. These are the parts you need to have.
Wait, for the second to last class limit, it says 137 to 158.
Yeah?
Okay. Oh, never mind.
Yeah, add 12 down here. 137 to 148 if you count it. 137, 38, 39, 40, 41, 42, 43. It comes out to 12. But what happens is when we do that, we have to subtract and add 1. So the easiest way is to do them down to sides. And then you don't mess that part up. Now, your frequency bar graph, guys, ignore the red lines in here right now because that's your frequency polygon. This is your frequency bar graph. This is your most popular bar graph. Hint, most popular. And you can do one of two things. You can either do the midpoints or you can do a lower class and then set it up that way. Easiest way is with the midpoint. Remember, we don't write the class in here 101 to 112. We don't write the class. We use the midpoint. Put the midpoint in here and make your bars touch. That was the idea about using the midpoint. It kind of takes the gap for your class boundaries. Make your bar label frequency, class in times and minutes, whatever this happens to be. Your frequency polygon is the midpoint, is the line graph. Oh, Mrs. Storm. Hi, good, how are you? Yes. Sure will. Okay, thanks, bye. Kristen, attendance when we're over. Okay. Relative frequency, guys, do you see that your relative frequency looks just like your frequency histogram?
Did you start with that one in 106 or what's the number?
I would start with 106. I've moved this over because of your frequency polygon. Your frequency polygon would has to drop one level down, one midpoint down. It has to have a starting point. Otherwise, that would start right there. I kind of cheated. I used the same graph because it is basically your same setup. You just have to extend it down here and extend it one over because otherwise it will be sitting right in the middle of your graph. But you can see your relative frequency bars. They look the same as these. They are. The only difference is how I label the y-axis. So again, use midpoints. It's a lot easier. Now, your ogive. This is called your ogive. This is your cumulative frequency. Make sure you set your y up for cumulative. And then notice we used all the endpoints here. We used the 106. I used your midpoint. I guess I used your midpoint. Just drop it down one and leave the end open. Otherwise, you would start here and go up and not have anything here. So make sure you just drop it down one, just like you did the frequency polygon. Okay? Leave your ogive hanging up there because it shows growth.
Did you have to simplify time? Like, was the control up?
No, absolutely not. No. How did you set it up?
I did it by 2 reasons.
Oh, you have a lot more room?
Yeah.
Okay.
The one that's the more drastic.
Oh, yeah, yeah, and yours are close, yeah. Just make sure that these are evenly spaced. Like, don't start your 5 down here because that's where 0 is. Make sure they're evenly spaced. And you should just pick an increment that works for you. 2 is probably a lot easier. 3, you could do whatever. You know, whatever you feel like it. And remember the bars too. Sometimes you see this where they put it right on top of the bar. Each one. This was a 3, this was an 11, this was a 7, 2, 2. Sometimes they put the number right on top of the bar. Make it easier to see. Know how to do, especially your relative frequency. Know how to set this table up. Know how to do this. I like this kind of problem. It's a nice little problem. It takes a little bit longer maybe, but... And your box and whisker, you can put these in your calculator and get your 5 summary numbers that are on the bottom there. Just put all your data into your L1. Do your 1-var stat. Put your data in L1. Do your 1-var stat. And your last 5 are called your 5 summary numbers. Make a number line from the minimum to the maximum. And then your 5 numbers, put a little tick mark for each one. The middle 3 is a box, and then it extends to your whiskers. The most important thing is this is your number line. Remember to give these things titles and label any axes. That's important. Graphs are organizers. These are the things you present. So really they have to tell your story. And you have to keep them nice and neat. Okay, here's a circle graph. A circle graph, again, is kind of like your relative frequency, part over whole. Add them up. Add them all up and figure out they all added up 14.1, 10, 21.7, 31. They added up to 77.9. 14.1 over 77.9. 32.1 over 77. That's where these come from. That way, your percents will add up to 100. Now, when you start your graph, an easy way to start, and I saw Anthony and Heather starting like that, with the quarters. Okay, so find one like 28, or find 2 that come close to whatever it is you feel you're doing, like 28. So I'm a little bit more. No one's going to measure, but I don't want to see 28 up here. You know what I mean? I need to see 28 a little past the 25. So kind of give a good estimate. 28, if these are 25, then this gives me 22 left over. So yeah, maybe I want to go for the 18. And then I have 4. Maybe I want to go for the 3. Oh, this is a 13, sorry. Maybe I want to do a 13. 41 should definitely be less than 50. And that's a good size for 41. As long as it's reasonable, I'm not going to measure. We don't have to use angles in this. Just keep it reasonable. And make sure you put your percent and your label for each group in there. And again, give it a title. A Pareto goes from the highest to the lowest. You want to be able to see where your problems are or your good things are, like the highest amount of sales, what group is doing the highest sales, maybe where are my highest expenditures, highest to lowest. This brought you back, number 7. Did you guys have questions? Did I go too fast? Okay, this brought you back to your bell curve. This was our empirical rule. Plus or minus 1, plus or minus 2, plus or minus 3. I put that in here as well. It's on the 3rd page. There's your empirical rule. Plus or minus 1%, 1 standard deviation is about 68%, 68.2%. Plus or minus 2 standard deviations is about 95.4%. We use like 95. Plus or minus 3 standard deviations is 99.7% of your data. So that's all I was asking for there. An easy way to start is like start your bell curve, put your mean in the middle, 1, 2, 3 again. This kind of takes us back a little bit before we did z-scores. Start with your mean in the middle and add 1 standard deviation. And add another standard deviation. Just keep adding your standard deviations. So 95% of your data is from here to here. Then subtract this, and this will come down to here. So where does 95% fall? Between these two numbers. Okay? This is prior to when we did z-scores. Just looking at your empirical curve. If you know that your empirical curve is 90, 68, 95, 99.7, that is good. Okay. Then we did z-scores. This is your basic z-score formula for populations. Remember your basic formula for populations. Also, I will give you the formulas. The sheet that I gave you that has each chapter laid out, I'm going to give you that on your final as well. It's got and it even has some nice little definitions in there. Nothing from chapter 1, because I think it's just like the definitions with your nominals and things like that, chapter 1. But from chapter 2 on, they have some nice formulas and things like that. If you rather the formula sheet that I gave you to hand out, I can give you that instead. Whatever you prefer me to do. So again, we use the ones in here in exercise 7 and we find the z-scores. So use this information that the mean was 155,000 and the standard deviation was 15,000. You need to know those two things. Plug them into your z-score, and now we found our z-scores. And you can see what makes sense. If it's less than the mean, it has to be a negative z-score. If it's greater than the mean, it has to be a positive z-score. Yes?
So like, if it's unusual, it's just like, whatever, if it looks like it.
No, unusual is this. If it's, guys, if it's -2, +2, or in that area, we consider, if your z-score is that far away from the mean, we consider it unusual. If it's -3 to +3, that far away from the mean, we consider that to be very unusual. That's the way we kind of look at it. This is extremely unusual. The -6.67, that's even off our chart. That's way out here somewhere. Remember, that does go out forever. It never stops. It just gets really, really, really small after. So that would be very unusual. ±1 standard deviation is where you want most of your data to sit. That's 68% of your data sits right there. And then inside the ±2, that's 95% of your data is there. So it's going to be rare that the rest of it is going to fall outside of that. Okay, this table, hang on for 1 second, because I don't want to move the, okay, let's go through these. It says, what is the probability? Remember, probabilities, when they ask for probability falls between 0 and 1. Probability cannot be a whole number. It's a partial, part over whole. So if I say how many are there, how many ways, how many people, then you give me the number. If I say what is the probability, part over whole. So what is the probability that someone earned a bachelor's degree? Find your bachelor's degree over the total. That's your probability. Part over whole. Not just the males, not just the bachelor. Sorry, I'm safe here. Not just the males, all the bachelor's degrees. Total bachelor's degrees over your total in the thing. If I say the males, then I want 553 over 2466. females, I want 769 over 2466. If I want all, part over whole. Okay? The next one said, I'm not going to move this, so you have to just follow. Earn the bachelor's degree given that the person is a female. Go to the given part, female, circle it. Bachelor's degree, find where that is, right here. So you're in this column, bachelor's degree over 1460. That's where you're getting your answers from. Okay? The next one, I kind of played with the words a little bit. It said, earned a bachelor's degree given that the person is not a female. So if the person is not a female, what is it? A male. So we're in the males, bachelor degree over total. God bless you.
Do you get the decimal?
If you convert either one of two ways, reduced fraction or decimal 3 places. So if you're going to put it in your calculator anyway, decimal 3 places is easier. I happen to like the decimals better. I'll move this in a second. I'll show you. If you're comparing to say like what one has a better probability, the decimals are easier to look at and compare. Fractions, if you've already reduced them, are harder. So I kind of usually stick with the decimals. Okay, a couple more, guys. Earned an associate's degree or a bachelor's degree. Remember, these are mutually exclusive. Does anybody remember what mutually exclusive means? Mutually exclusive, when something's mutually exclusive, they cannot happen at the same time. So either they earned an associate as their highest degree, or they earned a bachelor's as their highest degree. Bachelor's, associates. You add these over the total. They're mutually exclusive. They have nothing in common. Earned a doctorate, given that the person is a male, find the males. Earned a doctorate, 25 over 1006. Okay. This one's tricky. Earned a master's degree or is a female. So we want all our females and we want all our master's degrees. So we want this total, 467, and we want this total, 1460. However, where they overlap, we counted twice. So we counted this number in this row here and in this column. So you're going to have to subtract out your 270 and then put it over your 2466. These are not mutually exclusive. You can be a female and earn a master's degree. If I say and, then I only want 270. If I say or, you can be a female or earn that, but you have to subtract out the duplicate part.
So we add the 467.
Add the 467 to the 1460 and subtract out the 270. You got to subtract out the ones that they have in common. Where did I put it? Or is a female. Subtract out the 270. This is what you're subtracting out. Where did they overlap? Earned an associate and as a male, you have two ways to do this. You can take your probabilities and multiply them, or an easier way to do this is and is a male, associate male, take the associate male over your total. That's even easier. And the last one is a female given that they've earned a bachelor's degree. This time our given is this way. So the total is going to be right here. This is going to be your total. So female, 769 over your total. Okay? I guess we're kind of short on time here.